In order to understand how growing wild lupin, Lupinus perennis, a legume, indicates the level of soil fertility, it is first necessary to become informed on the characteristics of legumes in general. The late soil scientist William Albrecht, Ph.D., provides the following two quotes on this matter. The first quote is taken from the Albrecht Papers, Volume 4, Chapter 3, Salts for the Wounds of Agriculture. There is no substitute for soil fertility. Quote, with respect to agricultural crops, it must be taken into consideration the facts, A, that soil is being exhausted by any crop order or arrangement under soil management that disregards fertility return. B, that legumes are ravenous consumers of calcium, magnesium, phosphorus, potassium, and others. C, that they are nitrogen fixers rather than only soil nitrogen consumers when generously supplied with calcium and other essential soil bases. And D, that grass sod or non-leguminous crops, as well as legumes, are becoming less effective for their own preservation or for forage feed production under increasing soil acidity or rather base deficiency, end quote. The second quote is taken from the Albrecht Papers, Volume 1, Background Lesson Number 2, It's a Soil That Feeds Us, 5, Quality as Feed, Not Only Quality as Crop, demonstrates the effects of soil fertility. Quote, certain big plants are more apt to be indicators of fertile soils than others. But for that, one must know something about what the plant is creating or making while it is growing. Crops, like the legumes, which are said hard to grow, are usually indicators of fertile soils when they are making big plants and especially a big output of seed. It is this reproductive aspect, the activity of making new cells, of creating proteins, through which alone life keeps flowing, and of multiplying its parts and its species that really reports the fertile soils. Plants in nature are big and numerous because they have been multiplying themselves via production of more protein. The production of protein by plants is the real index of the fertility of the soil under the plants, end quote. The lupin in the picture is one of the original plants started in 2016 in the garden area of the yard. It's said about the wild lupin that it's a short-lived perennial living 3 to 4 years. In 2019, it had 30 inflorescences that produced over 2,000 seeds. This year, it still has over 20 inflorescences. The plant beside it is an oxeye sunflower, also known as the false sunflower. This plant was also started in 2016. When you remove crops in agriculture, as Albrecht pointed out, you are removing the minerals from the soil required for protein production. Without returning these minerals, usually on an annual basis, the soil becomes exhausted. Experiments lasting 50 to 60 years at his College of Agriculture have demonstrated the consequences of not returning minerals to the soil compared to returning them. Although the wild lupin is not being removed as a crop, in nature there's another agent that's exhausting the soil fertility very slowly over time. The agent is rain. The rainwater falling on soil is slowly working its way to the sea. On its way, minerals in the soil are being dissolved. This can be seen as scale in the kettle. Eventually, the soil can become just as exhausted as removing crops annually without returning minerals to the soil. The last period of increasing soil fertility took place in the last ice age. As with glaciers today, they flow downhill, grinding up rocks beneath them. In the winter, glaciers grow, while in the summer, they melt back. This meltwater carries the silt ground up by the glaciers across the land. During the period of glaciation and after the glaciers finally recede, continuing rainfall breaks the minerals out of the silt to make them available to plants and microbes in the soil, while it also carries some of these minerals to the sea. Increasing annual rainfalls will thus develop soils faster and then exhaust them faster without any interference from us. That is why the soil fertility increases as you go west across the continent to the area where the bison used to roam. West from there to the Rocky Mountains, there was not enough annual rainfall to create much soil fertility. Is it any wonder, since the last ice age ended so long ago, that the soil fertility is no longer the same as it was once to support the species that require higher protein values, thereby leading those species towards extinction? In his first quote with respect to legumes, Albrecht stated that legumes are ravenous consumers of calcium, magnesium, phosphorus, potassium, and others. It is widely believed that naming the lupin after Lupus the wolf was an error. Albrecht's statement in this regard contradicts this belief. In the same quote, he then stated that they are nitrogen fixers rather than only soil nitrogen consumers when generously supplied with calcium and other essential soil bases. It is widely believed that legumes improve the soil fertility where they are growing by adding nitrogen to the soil. His statement in this regard explains that this nitrogen fixation by microbes on its roots only takes place in high soil fertility. Genetics gives a legume the potential for nitrogen fixation to take place, but does not assure that it takes place under all soil conditions. Albrecht's second quote suggests to me the growing wild lupin as a way to determine the levels of soil fertility without doing a soil test. If you have an area where you can grow some wild lupin, you might grow it in 2 adjacent little plots where you modify the soil in only one plot in order to increase the ability of the soil to produce protein. In the event that you live in an area where wild lupin is growing in a park or conservation area, you might only grow it in one little plot where you have improved the ability of the soil to produce protein. Comparing the lupin in your plot with the lupin growing in the local area should indicate whether or not your lupin is growing in better soil fertility. If you do not live in an area where wild lupin grows, you might be able to use a lupin that grows in your area. For instance, if you live in the San Francisco area, you could grow silvery lupin, the preferred source of food for the caterpillar of the mission blue butterfly. On Milagro Ridge near San Francisco, the Golden Gate National Parks Conservancy is planting summer lupin as silvery lupin is losing its flowers and leaves to a fungal pathogen. If you can successfully grow silvery lupin in a soil better able to produce protein than the soil on Milagro Ridge, you could then introduce the pathogen into your plot to see if the plants you have grown are resistant to the pathogen. If they are resistant to the pathogen, you could be of great assistance to the Conservancy in reestablishing both the silvery lupin and the mission blue butterfly to Milagro Ridge.